This is the fourth in a series of videos in which I'm developing a logic comparator. This project came to mind when I was trying to find a logic comparator on eBay, and I was in particular looking for an HP 18-pin logic comparator. I did find one, but it would have cost me around £1,000 by the time that I'd paid import duty and shipping. So I decided that I could just as easily make my own. It might take a bit of effort, but it shouldn't be too tricky. And while I was contemplating this, I decided that why limit it to 18 pins? I might as well expand the design, and that's what I've done. I've gone up to what amounts to a 40-pin or 40-channel logic comparator. And the more I thought about it, the more I realised that other people might find this of use. So rather than just making a one-off, I've decided to make something that would be available to other people. So I'll be selling the boards as bare boards, or maybe even as complete units once they're ready. And to help with that, I also realised that maybe not everyone wants a 40-pin version or wants to build a cheaper version. So the way I've gone about designing this is to make it fairly expandable and modular. So at the very least you'll need one display board, which is this, and then you'll use one or more of the module cards, which I'll come back to in a few minutes. When I started looking at this and doing the basic design, the actual comparator part of the circuitry was relatively straightforward. Where it got complicated was in the interconnections for a device like this that supports 40 channels. And to give you an idea of this, this is the schematic for the display board, and there are several other schematics in this design now. You've got one for the comparators themselves, and then yet another one for the interface for the modules. So needless to say, it's quite a task getting this onto reasonably sized boards, and that was one of my main concerns. I want something that's about the size of the average multimeter. So I'll just grab a multimeter. So that's what I was aiming for, and you can see it's ended up pretty much at that size. So I've spent the last few days designing the circuits and then designing the boards. As I say, I wanted to make it modular, so what I've ended up with is a display board, and then we have the comparator board. And I've decided to make each of the comparator boards 20 channel. So this is a 20 channel comparator board, and if you imagine these as finished boards, there'll be sill connectors down each side. You'll notice they're different sizes, so it can't be inserted incorrectly, and that then will essentially be plugged onto the back of the display board. But in order to make it expandable, I wanted the builder to be able to maybe start off with one of these boards, and then later, if they want to, they can expand it into a 40 channel version. And to that end, what you do is you just get a second card. Now originally these cards would have been different, so you would have a top card and a bottom card, but I wanted to avoid that. And I also wanted to make it future proof, so if ever I bring out another version of this that has a microprocessor controller for selecting the device, I wanted to be able to reuse these. So if you've invested in buying these boards, albeit they're not very expensive, but I didn't want you to have to buy new ones if I upgrade this system in the future. So the way this works is you plug the first board in, and then the second board plugs in, but you just rotate it by 180 degrees. And then it plugs in again to the same display card. So the top card is the first 20 pins and the bottom card is the second 20 pins. So it'll support up to 40 pins in total. To select the individual device types, bear in mind this is not a dedicated tester for specific types of chips. This will test just about anything that works off a 5-volt realm. Then what you do is you have one or more of these module cards, and although it looks a bit complicated, most of this is just track that you won't normally see. But the way these work is you plug the device you want to compare, this is your reference device, into the module card, and then any pins that are inputs to the device, you just solder bridge these little jumpers. So rather than using physical jumpers, I'm just using solder bridges to keep the cost down and also to make it easier to implement the unit. And once you've got that configured, this slots in to the top card. There's a connector that will sit on the underside of this card, and that was one of the main design challenges, was finding a suitable connector. But I have done that. I found one that's ideal for this function. So these will slide in. There'll be guide rails down both sides, which I'll also supply. This slots in, and once it's plugged in, if you imagine, it will sit something like that. So you won't see the jumpers, you'll just see the device that you've plugged into it. And then down each side you've got the error indicator LEDs. So that was the basic configuration done. This is now all done, it's all designed. I'm ordering some prototype boards today. But the next design question was about the test clips. So this will use the DIL type test clips. Bear in mind, this is an in-circuit tester, so you'll be testing the devices while they're in circuit, and you're effectively comparing it against your reference device. But if you have a 40-pin DIL test clip, it's obviously not going to fit onto something like this. So you would then need one for 14 pin, one for 16, one for 18, 24, and it was going to get very complicated. And I originally thought of having multiple sockets, but that was going to get fairly cumbersome and also make it quite expensive for anyone to use, because you'd have to have multiple test cables. So the way I've arranged this, again, there's a single test clip now. This is a 40-pin dual inline, so it's 2 times 20 pin. The pins are configured something like this, and the way that it will actually be used, or the way it's the pins are connected, if you imagine if you turn this on its side, then effectively pin 1 is pin 1 of the device, then this pin is the top pin, this pin, this pin. So in other words, you can just select the number of pins you want to use. So if you select the first 7, then you've effectively got a 14-pin device, and you just plug a 14-pin connector into the left-hand side of the socket. If you want 16 pins, then you'll just use the first 16. And they're arranged in pairs so that it directly matches the actual devices. You don't need lots of different connectors and test cables. And this is the idea, is to try and keep it as simple and as practical as possible. So I put quite a lot of thought into making sure that it was going to be practical to use, and hopefully that's what I've achieved. And as long as it works, of course, then I think it's going to be an extremely useful tool. So as I said, I'm going to get the boards ordered today. They should be in around a week to 10 days. I'll get some prototypes built, and then I'll come back and show whether it works or not, and how to use it. Hopefully you find that of some interest, and again, if this is something you think you'd be interested in, then please let me know. Comments, as ever, are welcome.